and now for opening, I give microphone to Rector of Environment.Technology.Resources2023.
Good morning, everyone. Distinguished guests. Good morning, everyone. Distinguished guests and participants of International Scientific Conference, it's my honor and great pleasure to welcome you to Resume Academy of Technologies. Of course, it is a very important event for us. And if you ask me why, first of all, this event is a great opportunity to invite our friends, our partners from Latvian universities, from other Latvian universities, from foreign universities. And we are really thankful for you coming here and joining to us. Because here is a place we can share our ideas, catch new ideas, develop new projects, and of course do networking. Second reason, I think it's quality of our scientific articles. If I look through the program on this conference, we can see that all topics are in line with today's futures. Today's and the futures and these challenges of future. And now I would like to thank all participants for your input. But my biggest thanks goes to my colleagues. Thank you very much to organizing committee, to scientific committee for a great done job. And I invite you to enjoy our hospitality. And I really hope I really believe that you will enjoy, spend time here in Rezekne. Good luck, fruitful day, and I hope to see you next year in this conference too. Thank you.
Now I invite Chairman of Chairmans, founder of this conference, Professor Dr. Snowy.
Good morning, dear participants of conference, guests, all friends and colleagues. Thank you for your existence, for your presence of this conference, because it is very, very important for you and for us too, because you are able at this conference to deliver for public your latest and more important achievements in your work, and by presentation, oral presentation, and by through our publications in proceedings of conference. There are very many conferences in the world, large ones, small, global and local conferences. I can't say, I can't dare to say that our conference is something very, very special or very important, but this conference is a conference, a standard conference, other international conference with what have now now it is for 26 years old, and it is proved to be very important and very necessary for many scholars, researchers, and practitioners from Latvia and from very many other countries. Our conference, the aim of our conference is set at this conference name. The name of our conference are only three words. Environment, technology, resources. But these three words are pillars of development, of existence, and progress of all mankind. Because environment, it is our place for living, only place, our home, and we must to protect it, to take part in strengthen the quality and standards of environment. Technology is all activities of the human bodies, and so we must use this technology very smart. Technology must be very efficient and powerful, because it is basis of existence of our community. And the next one, it is resources. Resources are all goods of our existence, which we can obtain from nature, from environment, from ecosystems, and so it is necessary to use them very carefully and with high efficiency. And so all these problems and themes are in our conference content. Now our conference presentations aim on these problems, and I wish you to have very successful, fruitful, and productive work these 2 days in our Rezekne Academy of Technologies. Good luck and forward.
Now me, Dean of Faculty of Engineering, Markus Stēlāns. Many thanks to my colleagues to help organize this conference, to rectorate, to colleagues from other faculties. I think a lot of tasks are done and well done. And thanks to all participants that you selected our conference for presenting your work during 1, 2, or 3 last years, and present your work in our conference. And from me, just statistics. What fields are covered in our conference? Engineering, environmental engineering, nature protection, sustainable agriculture, rural development, smart rural development, energy field, material science and mechanics, metalworking and laser technologies, then different kind of modeling, mathematical modeling, socio-technical system modeling, simulation, information technologies in general, and different kinds of engineering education fields. Participants and reviewers represent 17 countries. And what is interesting, contrary to previous conference, in previous conference mostly 50% was Latvians, but now the situation is a little bit different. Who is the biggest community from which country? 40% of participants in this conference, this is the biggest community of scientists and practitioners, comes from Bulgaria. This year, thanks to Bulgarians. 30% from Latvia, 10% from Ukraine, and other countries 16%. Germany, Poland, Estonia, Lithuania, Spain, Kazakhstan. Thanks participants from all countries. Now we have around 30% of engineer ladies. It is very good number because this average in the world is in engineering field, female engineers are only 6%. In our conference, it's around 30%. It's very good result. Thanks for ladies. What's different in this conference? It is again due to last pandemic. Now scientists like to work remotely, from home, from laboratories, from business trips, and in this conference, the first time we open dual participations. Participants can participate on site and remotely. And now about 50 authors are on site, and about 70 are remotely. And we translate on YouTube our plenary session and opening session. And as well, in parallel, each day 2 sessions will be on site and 2 sessions remotely. These remote sessions as well will be organized from our lesson rooms, and participants on site can attend these remote sessions if you found some interesting topics as well. No problem, remote authors can't attend these sessions on site. And about publications, now all of you received USB sticks, and all conference proceedings you have on sticks, and as well all conference proceedings are already published in our journals from conference site. You can open as well journals, and all conference proceedings are published in journals as well. And as usual, usual, after the conference, we submit proceedings to Scopus organization, and I hope near to autumn they will be indexed in Scopus as well. And thanks again for this good scientific quality of your papers, and thanks that you selected Rezekne as place where to present your work. And now the next session, thank you Director, and now next session organizers select 3 papers for presentation in a plenary session. These papers are from different fields. This is correct time for starting. In a plenary session, first paper which is selected for plenary session, authors comes from Rezekne Academy of Technologies, from as I see from other Latvian institutes as well. Speaker is our Professor Sergejs Kodors, and rapid prototyping of peer detection, neural network with YOLO architecture and photographs. Sergej, floor is yours. And problem, you should speak in a microphone because this session is translated in a YouTube.
To open this session. My name is Sergejs Kodors, and today I will present the result of our large project, which is directed on to develop autonomous unmanned air vehicle-based decision-making system for smart fluid growing, and this publication is related with our artificial intelligence. Maybe what I need to say to thanks to my team. Our team is large, somewhere 20 people, and really it's a result of teamwork, and people who presented are related exactly with variety. It's a very interesting project because we are developing eco-cyber physical system based on digital twin paradigm and artificial intelligence usage. So the concept is sufficiently simple. We have drones which must fly around the garden to detect objects. It's different couches, apples, cherries, pears. We can detect diseases, and we can count yield to predict in season time and in the next year. So we have plenty of work packages. And if we're speaking about digital twin, it is related with user application when we can monitoring all this process remotely and control drones to using this platform. previous year we had presentation of this system. We have already implemented digital twin platform, which provide possibility to digitize Orchard, to connect DJI drones using Android station, which controls and send data to server for next processing. Maybe speaking about DJI drones, we have restrictions. The flight precision must be sufficiently high, 5 centimeters, and therefore, if we speak about practical usage, it's require RTK technology and some cheap solutions like DJI Mini. Our DJI Air is not compatible for these tasks. Only professional versions, but we have some ideas. And speaking about actual works, we requested our mechatronic department to help with our own drone development, which will close all weak points of current enterprise solutions, and we plan to demo this solution in this year, somewhere in August. It will be our next living lamp demonstration. Second part, it is risk analysis. So we are developing safety artificial based system, so because it's very now actual direction that yes, we can develop sufficiently good solution with artificial intelligence, but all this solution must be safety for human, and this safety is related with different directions, and in this case it is human robots communications, and now we have included some protections for our system, and actual one work, it's exactly year old forecasting, and today I will present rapid development, because our solution is prepared for commercialization, and we must have fast possibility to retrain, to provide other fruits for our system. So, speaking about ECO, cyber physical system, what we understand about ECO, it means that we must consider all risk factors which come from environment. They can be positive, they can be negative, and we define mathematical model, key performance indices, which are important for fluid growers to make their decisions, and provide all this information in dashboard, in recommendation system level. And if we're speaking about cyber physical system, it's connection between software, artificial intelligence, and drones. So drones play platform role. They fly around garden. We collect data. We can calculate current yield amount, yield estimation, and when we have the history of yield estimation, we can make yield forecasting based on our previous history. And speaking about this publication, it's related with stage yield estimation, when we need to count correct number of Yes, important maybe thing for our solution is prepared for modern orchards when we have hedge of trees, not old solutions. So, novelty of this publication. Firstly, we present new open dataset with peer collection. All data are annotated. And if we're speaking about current situation, there are restricted number of open datasets. You can fly sufficiently many publications, but dataset is not available. You have some restrictions that you need specially write and get license and etc. Our dataset is totally open and under CC BY license before you can use it and for commercialization. Second direction, it's natural images. The previous datasets were collected in the laboratory conditions. We consider the best practice which provides more natural usable decision from artificial intelligence because it's trained in real situations. And the results of projects will be multi-class datasets, but we need some time more. And speaking about research, we developed rapid prototyping solutions comparing the existing framework for cheap development, so that we have data we can input into system and get good results for our prototype. And we need small effective neural network because there are one problem. Yes, neural network is working fastly, somewhere 20 maybe milliseconds to process, but when you need process millions photo in parallelly, of course we need some parallelization and cluster resources. So our dataset already is published in Kaggle system. We have published 4 already datasets from previous projects, and we plan to continue. Result of our current project will be more 3 datasets. So about experiment, we have taken 3 open datasets, including our, to get some comparative data with current state and to have results with different cultures, because it's important for us. And we selected YOLO 5, YOLO 7 models. We have planned this experiment design in November, and now Ultrasonics company have announced the YOLO 8 framework. I think it will be the most popular in the close 2-3 months. But we have tested only on YOLO 5 and 7 because experiment was completed in the December. And there are very interesting results. Considering the original publication, YOLO 7 is better than the YOLO 5, but our experiment showed that we have similar results in the case of wine. If we have find some similar researches, they provide similar statistics. Therefore, speaking about model 7, we consider that there will be similar situation. But if we take Apple recognition and peer recognition, new model is not so powerful. We have analyzed the problems, and problems are related with the size of bounded boxes, object size, and their intersection. So, therefore, some new, not only the best, and you need make experimentation to take the best solution. Considering our analysis, the most suitable was YOLO 5 middle model because it's sufficiently small, and at the similar time it provides sufficiently high results way fastly, and this model will be used in our next experimentation and developing the prototype of our system. Maybe I will repeat main case of our novelty of this publication. It's exactly an answer of open dataset P64. Why 640? It's size of standard input of YOLO model, and we recommend to use YOLO 5 middle model for rapid development if someone wants get fastly results with agriculture recognition. Thank you for your attention.
Thank you, Sergei. Questions from colleagues?
As I understood, you are more concentrated on fruits for detecting roids. It's for other seasons too. For example, by branches or by flowers.
We concentrate exactly on fruits. It's our main goal of our prototype to provide the autonomous orchard. If we is speaking about thermal orchard and garden, there are difference. That garden provides possibility for flowers, orchards only fruits. And if we're speaking about results, these results are exactly compatible with fruit detection. We can't say how it works on flowers. We can see that YOLO 7 is more worse than YOLO 5, but it's related exactly with size of apples and pears and their intersection. Therefore, if we're speaking about flowers, if flower will be large, for example, sunflower, I think YOLO 7 will be similarly based good. But if we speak about some small flowers, many intersection, we can get similar results. But if we compare with original papers, they were oriented on 1,000 classes, different humans, cars, birds, and other, it's other domain. And this result will be not compatible to this. Therefore, it's exactly this fruit detection.
Thank you.
Thank you. I have just practical question about size of training network. Is it possible to run on board or always I need cloud?
Your middle model is sufficient to process it using tiny machine learning. It's all edge detection solutions using microcontrollers, for example, Arduino or Raspberry.
Thanks. questions? Thank you to Sergei. Next speakers from Riga Technical University, Department of Technical Mechanics. Karunamorsi Rangasani. Correct?
Yes, correct. Good morning, ladies and gentlemen. I'm Karunamurthy from Riga Technical University. I am a second year PhD student. I'm doing research in concrete using steel fibers. What happens if you are heating the concrete in a higher temperature? What happens to the ingredients? That's what I'm researching on it. And then here I'm going to present a topic on ingredients degradation in a short fiber reinforced concrete when it is subjected to thermal loading. So, like, I was supported with the project named Ikonde, and then we are like collaborating with Norwegian peoples and then Lithuanian and then Estonian peoples as well. So, and then my professor like Andrews, he's a chairperson of this project, and then here is the main like motto of our research is like the concrete samples, like we heated the concrete slabs and then up to 800 degrees Celsius. After that, those like we separated the fibers. We used steel fibers into the concrete. We separated the steel fibers and then we tested it, because like if you are treating the concrete in higher temperature, like it may lead to break or explode, something like that, right? So exactly our research is what happens when it is subjected to overheat, or if it is like in our building some fire accident or something is happened, the building is going to be collapsed. So what happened exactly when the like overheat or fire is subjected to the concrete wall or slabs? So in the research we took a big slab which is like 16.5 centimeter of thickness, and then we heated from one side of the slab. One side is like not heated with the fire, one side we applied the fire. So after that what we did means like we just separated the fibers from the heated end, like from heated end to, we separated every band like from 1 centimeter. So we separated into 16 sets of bandwidth. So the fibers what we used in the slab is like it's a hinged hooked fiber. So this one is with 6 centimeter of length. Each short fiber is 6 centimeter of length, and the diameter is like 0.75 mm. And then these fibers we separated from heated end towards the non-heated end. So after collecting the fibers, we plan to check like fibers quality and then how it was. After that we did a pull-out test as well. So here in the top corner you can see like two kind of fibers are there. So first one is like the fiber we took from non-heated end, and then this one is fiber we took from the heated end. So here you can see like visibly, like we can see like a lot of oxidation occurs on the fibers, which one is because of that high temperature. Like the fibers ferrous, which is treated with water content moisture in the concrete, and then like it becomes like more oxidized, and then due to this oxidation, like concrete gets peaks, and then this is going to be collapsed. That's what we got results. And then after seeing these one in the microscope analysis, after that we prepared a pull-out samples. These pull-out samples, why we did means we need to know how big strength these fibers can give. So like that one also we prepared samples like 16 sets. Each set is like 7 samples. So the results what I am giving here, like what I showed in this paper, it was like an average of 7 samples, and then these results like more than 130 samples we prepared, and then all these like compared, and then average results what I showed here. So the float which we applied in the force of 1000 Newton, and then like 5 minutes per sec, like 5 meters per second in the velocity we did our test. And then here is the test results of compression test. The like compression, and like we didn't use any quartz or stones in the concrete. We just used the plain with cement and then sand or water. Those like these are the ingredients what we used in the concrete, because like if you are adding stones or something else, like the concrete will become very stronger. So we can't able to find the exact strength of the steel fibers. That's why we took these kind of concrete. And then in that one, like compression, like the average the strength of the concrete, it was like 26.77 megapascal. It's while comparing to the other concrete, it was quite weaker, but we are not using the stones and all those stuff. That's why, like while seeing in that conditions, it was a very good result. And then during pillow, like we did for every 16 bandwidths we did, but due to this large thing, like I just showed the heated in and then non-heated in. I didn't show the results of in between, like 14 sets I didn't show here. So these are the results of the fiber which we took from the like non-heated end. So in non-heated end, the maximum strength which we got, like average value of the maximum strength, it was like 135.47 megapascal. So when it is compared to the heated end, it was the result was like 36.07. It was very low when we are comparing to the normal fiber. It was very weak, and then this fiber, how it becomes means when it is heated and then this oxidation occurs, and then the core of the fiber, it became very thin, like a thread or yarn, something like that. And then those steel fibers we can easily bend or crush with the hands itself. That much weak it was. So like when a steel fiber heated up to around 800 degrees Celsius, we heated. All these samples were heated up to 800 degrees Celsius. So in that case, the fiber was very weak, and then it shows strength like 36.07 megapascal. So this is what the results what we got on this research. And then yeah, that's it about my paper. So as I told, the strength of the fiber was like weakened, like 3 times lesser than the original one, like that is virgin fiber which we took from the non-heated end. So this is what the results. And then the load bearing capacity of the fiber also reduced very less. So yeah, that's it about my paper. So if you have any doubts, you can ask. Thank you.
Thank you, Marcy. Questions from colleagues? I have just one question. This is part of project research, or this is your PhD research?
Actually, like this is my PhD research. Actually, I am like including these research into my project is as well, like because our project is basically working on fly ash and then basalt fiber, all those things. Like right now, after that, I did with the basalt fibers and then ferrous using like I'm like continuously doing a lot of research. This is my first part of the research. That's what I shown here. But all these research was supported by the project.
And in what stage is PhD studies? Final stage?
No. Like I'm a second year student, still 2 more years.
Good luck for you.
Yeah, thank you so much. Do you have any other questions?
Yeah, thank you. Well, the situation is very complex because Next speaker should connect remotely. Luis. I can't see Luis. Sofia is here. Viņi mani dzird? Super. Sophia, next paper is yours. Do you hear me? No, I think I have technical problems. Realmente es doma. Oh, Sophia is connected.
Good morning, everybody. I have presentation, third section. My time?
Next, we select 3 papers for plenary session. And then this lifelong learning for talented management and professional development and employees is selected for this plenary session. Are you ready?
No, it's a topic for Professor Luis Ochoa Sequencia. I tried to connect with him.
But he's not connected.
Oh, it's not good.
Yeah, it's not good. No, don't worry. Then in regular section, you professor can present his paper.
So may I present now?
This lifelong learning.
No, I try to connect with.
Well, as usual, small problems, but maybe we solve it. And after this plenary session, we will start in regular sessions. You are free to ask colleagues at the registration desk where you have each room. Information technologies, you should cross campus in Information Technology Center or other sections here.
Dear organizers, may I present my topic and Professor Ochoa Sequencia will take active part in a third section?
In this section or right now, yeah?
Yes. I have a topic from Industry 4.0 paradigm towards Industry 5.0.
Yeah, why not?
Why not? Okay. May I share my screen?
Yeah, I make you as host. You should be able to share your screen.
Okay.
Please introduce yourself, and then we can start.
Okay, sorry for a problem. Ladies and gentlemen, good morning, everybody. Greetings from Krakow, and thanks for the organizers to the opportunity to participate online. I represent a team of authors, Professor Ochoa Sequencia, Professor Anna Szelong-Sikora, and Professor Agata Niemczyk. the main topic of my presentation is a speech for the Industry 4.0 paradigm towards to Industry 5.0. I also invite you to read our publication. And you see my presentation. I need the information from feedback. I hope everything is okay. Let's start. For many companies, Industry 4.0 is still the next thing that should focus on or the trend they are currently adapting their strategy to. It reflects the fourth industrial revolution triggered enabled by developments in IT. Key elements include automation, robotization, big data analytics, smart systems, visualization, AI, machine learning, and Internet of Things. The concept of Industry 5.0 is a relatively new one. According to the European Union, Industry 5.0 provides a version of industry that aims beyond efficiency and productivity as the sole goals and reinforces the role and the contribution of industry to society. And it places the well-being of the worker at the center of the production process and uses new technologies to provide prosperity beyond jobs and growth while respecting the production limits of the planet. It complements the Industry 4.0 approach by original emphasis, specifically putting research and innovation at the service of the transition to sustainable, human-centric, and resilient European industry. And what's important? The idea of Industry 5.0 is not limited to industry. It applies to every sector and every organization one can think of. This means that the applicability is significantly wider than Industry 4.0. Therefore, when discussing the implications of Industry 5.0 for strategy, we need to take a broad and general perspective applying to all industries. As the European Commission spells out is the iconographic, Industry 5.0 has three key pillars: human-centric, resilient, and sustainability. All three have significant implications for a business strategy. The development of Industry 5.0 paradigm took a new term when the European Commission realized the perspective of European technology leaders on Europe's future industry agenda under the label of Industry 5.0. While discussing the challenges of the term Industry 5.0, this report proposed that Industry 5.0 should not be understood as a replacement or an alternative to, but an evolution and logical continuation of the existing Industry 4.0 paradigm. While acknowledging that Industry 5.0 is centered around human and ecological values, this report proposed that this phenomenon should ensure that novel technological innovation should be shaped towards supporting socio-environmental development. In 2021, the European Commission realized its Industry 5.0 agenda for resilient, sustainable, and human-centric European industry. According to this agenda, Industry 5.0 is a complementary exercise extending the Industry 4.0, arguing that this paradigm cannot be considered the proper framework from addressing the privileged climate crisis and social tensions. This policy document proposes that Industry 5.0 represents a new vision for the This policy document proposes that Industry 5.0 represents a new vision for the industry, redefining the role and the functionality of the value chain, a business model, and transformation in a hyper-connected business environment. According to this policy document and every recent academic contributors like Grabowska, Renda, and Medica, Industry 5.0 differs from Industry 4.0 in the following manners. And now, Industry 5.0 values both productivity-driven competitiveness and sustainable development. 5.0 empowers the human workforce via promoting human-centric approaches to technological development and advanced technological innovation, such as smart and renewable system in the realm of environmental sustainability. Industry 5.0 promotes stakeholder primacy in technology governance, innovation growth, and sustainability performance management, and draws on certain technologies and functional principles to expand the scope of corporate responsibility to the entire value chain. Next slide, please. Nowadays, there is a general agreement that Industry 5.0 differs from previous industrial revolution as it represents a stakeholder-pulled socio-technological phenomenon that systematically shifts classic profits and consumption-driven economic model to circular, regenerative, sustainable, and resilient value-creating economic model. In a European Commission's view, Industry 5.0 is a necessary evolutionary step of Industry 4.0 due to Industry 4.0 is not the right framework to achieve Europe's 2030 goals because the current digital economy is a winner-take-all model, creating a technological monopoly and gigantic wealth inequality. Industry 5.0 is not a technological leap forward, but a way of looking at the Industry 4.0 approach in a broader context, providing a regenerative purpose and focus of the technological transformation of industrial production for the benefit of people, planet, and prosperity. Industry 5.0 is a transformational model that reflects the evolution of the thinking after the COVID-19 pandemic, taking into account the lesson from the pandemic and the need to design an industrial system that is inherently more resilient to future shocks and truly integrates social and environmental principles. The notion of Industry 5.0 complementing and extending the distinctive features of Industry 4.0 suggests that they should be considered alongside the notion and extending the distinctive future. Industry 4.0 suggests that they should be considered alongside each other. For example, the coexisting of technology-based Industry 4.0 and value-based Industry 5.0. The growth and development model of Industry 5.0 is based on three fundamental pillars: ecology, human resilience. Industry 5.0 will benefit workers, entrepreneurs, and the environment. And changing the current approach will not only increase production efficiency, but also make more rational use of available natural resources and provide better working conditions. So thank you very much. Thank you for your attention, and I'm sorry for everything mistake.
Okay, thank you, Sophia. University of Economics. Questions from colleagues. Thanks for this introduction to Industry 5.0. I just one question. Maybe in Poland or other European countries, how you see, what is the readiness level currently? When we're talking about employees, employers, machinery, what is readiness level? Does we reach Industry 5.0 or not? Okay.
Yes, I am. What is important for us? In my opinion, especially sustainable industrial development. Because Industry 5.0 relies on the most disruptive technological innovations to achieve its core objectives of human centeredness, resilience, I say before, sustainability. Among other things, Agenda 21 adopts principles saying that humans are agents of sustainable development and have the right to live healthy and productive lives in harmony with nature. This transformation is intended to promote the development of society, influence, and the reduction of climate change and environmental degradation that to improve the quality of life to present and future generation. In an Industry 5.0 concept, the human factor regains its rightful place at the center of the production process. According to this approach, it is technology that should serve man, not the other way around, and the aim should therefore to be ensure full cooperation between humans and machines. What's important, in my opinion, Industry 5.0 complements the existing Industry 4.0 paradigm and rich in innovation drive the transition to a sustainable and European industry. And the European Economic and Social Committee Consulting Commission of Transition identified the key challenges of Industry 5.0 at the conference on 2018. And human-robots collaboration is a maker of a new economy where the role of human is changing in a new economy, where the role of humans is changing as there will be jobs operated autonomously by robots. The challenge will be the social and ethical risk associated with a new industrial revolution in which human will increasingly be replaced by machines to create Society 5.0. Society 5.0 is a new social model with human is in the center. Humans are a creator of content and analyze network and data, but they cannot share knowledge and information effectively without the digitalization and automatization. Therefore, there is a need for infrastructure and information system connected to people in cyberspace and artificial intelligence to process data and generate results into virtual space. The new generation of development is a super intelligent society based on the data and knowledge, such as human development trend in linked to smart manufacturing system and social infrastructure. That's all.
Thank you, Sophia.
Thank you so much.
Yeah,
Have a good day.
We are not so far from Industry 5.0. Artist, yeah. One more question, Sophia. Thank you very much. Yeah. Sophia, questions about this? No, I can't see Sophia. Sophia is on. Okay, sorry. Then I close this session and coffee break. Don't forget that at the evening we go by bus visit Medvedi Agricultural Technology Park and Greenery Malnau College. And the bus start in 16:30 from this building. Enjoy talking, and after 10 minutes, after 20 minutes, 10 minutes, after 10 minutes, regular sentence. Thank you.